In this video, we'll see what is a bottom-up parsing is. Bottom-up parsing is a reverse of top-down parsing. So here we start with the input symbol and keep on reduce it with its corresponding production, and finally it will leads to well starting symbol. Let me explain now with the help of example. Now let us consider a grammar. The grammar belongs to arithmetic expression. And we have input. That input belongs to this grammar. What is the input here? ID star ID. So how to perform the bottom up parsing here? See, in the bottom up parsing, look at the the string, first symbol in the string. It is ID, right? Okay, so look at the production rules of the grammar. You just check the body of the production. So the body of the production means the last production which contain F derives ID. Therefore, ID is replaced with F. Okay, now what is this? F star ID. Okay, in the first step, ID star ID is converted to F star ID. And after that, F will be, look at the production. So the convenient production. So F is replaced with the T. Now it is T star ID. Now look at this. So T star, after that I'm going to replace with T star ID, again is replaced with F. Next T star F is replaced with T. Now T is replaced with E. See, here the concept is the input. What is input? ID star ID. See, this is not actually the process of derivation. Whatever you studied, the concept of derivation in top-down parsing. So this is not the concept of derivation. What is derivation actually? Derivation means for the starting from the start symbol, we'll go on apply the production rule till we obtain the input string. Right. So something called the derivation, one step by step. But this concept is not derivation, but what is this called? This is called as a reduction process. In every step, okay, every step, the input symbol will start with the input symbol, and in every step, the input is replaced or reduced by a corresponding production. Okay, it is reduced. For example, look at the first step, ID star ID, and the first ID is reduced by F. How? Because F derives ID, right? So ID is reduced by F. In the second step, F is reduced by T. Okay, the third step, again the last ID is reduced by F. Hence T star F is reduced by T, and then T is reduced by E. We can think of bottom-up parsing as the process of reducing a string W to the start symbol of the grammar. At each reduction step, a specific substring matching the body of your production is replaced by a non-terminal at the head of that production. Okay, not the body but head of the production. Therefore, the key decision during bottom-up parsing are about when to reduce and about what production to apply as the parse proceeds. Okay, see here, so why this particular concept means when to reduce and which production to apply. So this is what the confusion here. So in general, bottom up parsing constructs a parse tree for an input string beginning at the leaves and working towards the root. So this is what our discussion, arithmetic grammar, and the corresponding input is ID star ID. The strings in the sequence are formed from the roots of all the subtree in the figure. The sequence starts with input string ID star ID. The first reduction process produces F star ID by reducing the leftmost ID to F. Look at this. ID is replaced by F. Okay, what is the production actually? F derives ID. Production body contains ID. What is the head here? F. So ID is replaced or reduced by F. Next, after that, Okay, we have F is replaced with T. Right, F is replaced with T. Now it is T star ID. Now let us consider we have a choice between reducing the string T, which is the body of E derives T, right? Now T can be replaced with E, or we have another choice. We have a string consisting of second ID, which is the body of F derives ID, right? We have a choice. Either we can replace T with E, or we can replace ID with F. But instead of going to the first choice, I'm taking the second choice now. So it is something like T star F now. So I did the second step, second reduction. ID is replaced with F. Now T star F is obviously replaced with T star F, that is T derives T star F, right? So this body is replaced with head T. So T is replaced with T star F. Now it is E. So the concept is the decision, right? We have to take a decision during bottom up parsing. So what is the decision? When to reduce and about what production to apply as the parsing proceeds. So this is what the question, right? So we'll discuss this concept, okay, in the later few slides. A reduction is a reverse of step in a derivation. The goal of a bottom-up parser is to construct a derivation in reverse. Let us consider this. Let us consider the start symbol. Start symbol derives, E derives T. T in terms derives T star F. Then T star F is replaced with T star ID. Then it is replaced with F star ID. Finally, it is ID star ID. This derivation, in fact, a rightmost derivation. So by definition, you just recall the definition, a derivation, a non-terminal in sentential form is replaced by a body of one of its production. Therefore, the goal of bottom-up parsing is therefore to construct a derivation in reverse. Okay, so this is something like the rightmost derivation, right, in reverse. Clear? Handle pruning. What is handle? A handle is a substring that matches the body of production. See, the reduction, as I explained in the previous slide, what is reduction? Reduction is derivation, but what type of derivation? Rightmost derivation in reverse. So with the help of example, let me explain what is handle. The same example now, ID star ID. So the first symbol from the leftmost, that is ID, right? I choose ID as a handle. So let me take the grammar now. Okay. So this is a handle. This exactly matches with head F, right? F derives ID. So now it is replaced with right sentential form is F star ID. Okay, F star ID. Now what is the handle? F. Production match. T derives F. Therefore, F handle is replaced with or reduced with T. So T star ID. T star ID, which is the handle now? T or ID? Confusion. But I select ID as a handle. Okay. Handle is reduced by F. Now what is handle? T star F. You just go through the grammar. You find whether the body of any production rule contain T star F. If so, T star F becomes the handle and reduce T star F with the corresponding head. What is that? T. Now T, handle is T, replaced with E. Okay, therefore, what is handle? Handle is a substring that matches the body of production. Clear? Okay, let me explain the concept very clear. So this is what our input ID star ID. ID is a red color, right? It is a handle reduced by F. F is a handle reduced by T. Now ID is a handle reduced by F. T star F is a handle reduced by T. So this is something like the rightmost derivation in reverse, right? Look at that. So we have something so from the top to bottom, it is rightmost derivation. But how we obtain this rightmost derivation? Going in reverse order. So that is called as a reduction. So every time the handle is converted to a corresponding production role. So this happens till we reach the start symbol. This step is called as handle pruning. Right? This step is called as handle pruning. Clear? So the types of bottom-up parsing are shift reduce parsing, LR parsing. Okay, so the basic version is shift reduce parsing, and the next is LR parsing. So LR parsing, there are three categories, that is SLR, that is simple LR parsing. The second one is canonical parsing, and the third one is look ahead parser. So we'll study one by one. So let us study the first one, that is shift reduce, a basic version of bottom up parser, that is shift reduce parsing. So we know what are the types of bottom up parsing, right? So in that, the basic parsing concept is shift reduce parsing. So in shift reduce parsing, what is shift reduce parsing? So shift reduce parsing uses two data structure. One is stack and the input buffer. I mean, in order to do the shift reduce parsing, so the parser uses two data structure. One is input buffer and other one is handle. So whatever we studied the concept in previous slides, something like handle pruning, everything is adopted here. Okay. So now what is the initial configuration of the stack? Initially, the stack is filled with a special symbol called dollar that indicates the beginning of the stack, and the input buffer is filled with input ending with dollar. That is what the initial configuration of shift reduce parsing. And we have something called the acceptance configuration, right? When the stack contain only the start symbol, dollar followed by start symbol, and the input buffer is empty, so that is only the dollar. At this time we can say that the shift reduce parsing, I mean this parser accept the input string. There is no syntax error, I mean the input is syntactically valid. Okay, that is confirmed by the parser. In general, in shift reduce parsing, the primary operations, what are the primary operations? One is the shift operation. So what is shift operation? Shift the next input symbol. See, we have input buffer, right? And pointer is pointing to the input buffer. I mean, it denote the input symbol. So that input symbol has to be pushed or shifted onto the stack, the top of the stack. Shift the next input symbol onto the top of the stack. So that is what the shift operation. Reduce means the string to be reduced must be at the top of the stack. That means parser will going to verify whether the um, handle is appeared on the top of the stack. Okay, so handle may be contain one or more symbol, not only the single. Okay, so top means it has to verify certain limit. Okay, limit of symbols, so that symbol becomes the handle. Means the string to be reduced must be at the top of the stack. Means locate the left end of the string within the stack and decide with what non-terminal to replace that string. So whenever the handle appears on the stack, so that has to be popped, and what is to be pushed? The corresponding non-terminal. Understood? Corresponding non-terminal has to be pushed onto the stack. The next is accept. Announces successful completion of the parsing. Error. Discover a syntax error and call an error recovery routine. Now consider the parser for the input ID star ID. Okay, how the shift reduce parsing will do the parsing. So initially the stack is loaded with the dollar and input is loaded with id star id dollar. Remember here, conventionally when we're discussing the bottom up parsing, we show the top of the stack on the right rather than the left. Okay. Now look at the input. So what action? We have shift and reduce actions, right? So which action we have to perform? Either shift or reduce. So I'll go for shift because input is id, that is shifted to the stack. What is the remaining input? Star id dollar. After that, the parser is going to verify the stack content. Whether the stack contain any handle now? Yes, id is a handle. If it is handle, what it has to do? It has to reduce id with appropriate non-terminal. Okay, now the perform is action is reduce by f. Input is star id dollar. Now again the parser verify the stack whether there is any handle. Yes, if there is any handle, so what it has to reduce? T derives f. It is with t. Now T star ID dollar. Okay, so now what happens? It will do the shift operation. Star is inserted to the stack. Okay, shift operation. Now T star, whether T star is a handle? No, there is no exact match. Therefore, it will shift ID. T star ID. Okay, now T star ID is a handle? No. Whether ID is a handle? Yes. ID is a handle. What it has to do? It has to perform the reduce. ID is replaced with F. Right. Now look at the stack. The parser again identify the stack, okay, for verifying the handle. T star F is a handle. So this is reduced by T. Now T is a handle. It is reduced by E. Now what is stack content? Start symbol. Top of the stack is capital E, which is the starting symbol. Whether input is empty? Yes, input is empty. Now what is the operation? Accept means it is syntactically valid. So there is no error occur. Starting from the input, it is reached to start symbol. Hence it is syntactically id star id is syntactically valid according to the grammar. Hence it is accepted by shift reduce parser. Conflicts during shift reduce parsing. There are context free grammars for which shift reduce parsing cannot be used. Every shift reduce parser for such grammar can reach a configuration in which the parser, knowing the entire stack content and the next input symbol, cannot decide whether to shift or to reduce. Okay, so it will somewhere it will get a confusion. It know the top of the stack. What is the top of the stack? Means you just try to understand handle. Okay, parser identify the handle on the top of the stack as well as input. Okay, input in the input symbol. So at this time it cannot decide whether to shift or to reduce. So this particular concept is called as shift reduce conflict. Okay, shift bar reduce conflict, or cannot decide which of the several reduction to make. So this is called as reduce conflict. So what is the two kinds of conflict? Shift reduce conflict or reduce conflict. So now let us consider this is the consider the example ambiguous grammar. So this can never be LR grammar. Okay. For example, consider the dangling else grammar. Statement derives if expression then statement, or if expression then statement else statement, or other. We know that this is the ambiguous grammar. So if we have a shift reduce parser in a configuration, look at that stack configuration is, so we don't know what is the rest of the stack content, but stack top is if expression then statement. And what is the input? The input current input is else followed by something. We cannot tell whether if expression then statement is a handle, no matter what appears below it on the stack. Here, there is a shift to reduce conflict. Depending on what follows the else on the input, it might be correct to reduce if expression then statement to statement, or it might be correct to shift else and then to look for another statement to complete the alternative if expression then statement else statement. Note that shift reduce parsing can be adopted to parse certain ambiguous grammar, such as if then else grammar. If we resolve the shift reduce conflict on else in favor of shifting, the parser will behave as we expect, associating each else with the previous unmatched then. So later we'll discuss the parser for such ambiguous grammar. Now let us consider one more example for shift reduce parsing. Now let us consider another example, that is S derives TL semicolon, T derives int or float, L derives L comma ID or ID. So let us verify the syntax, okay, of the input int ID comma ID semicolon. So this is what the input. So the grammar is given and the input is given. So what we have to do, we have to apply the shift reduce parsing for the input. Now initially what is the content of stack? Dollar, and input is int id comma dollar. Okay, so this is what the input. Initially what is the action? Shift. No confusion, right? Because input is int is pushed onto the stack. Shift means push operation. Now just look at the stack content int. What is the top of the stack? Int. Whether it is a handle? Yes, because t derives int. Therefore, this is what the remaining input. Therefore, what we have to do, we have to perform reduce operation. What is the reduce? Reduction. Int is popped and what is pushed? T. Okay, so int is reduced by T. Now, what is the input? ID. So whether T is a handle, look at the stack top. T is a handle? No. Now what we have to do? Look at the input. ID. So what we have to do? Shift it. Okay. Now what is the stack top? ID. Now what we have to do? Whether ID is a handle? Of course, ID is a handle. What is the remaining input? This is the remaining input. Okay, ID is a handle that is replaced by L. Means ID is popped out. Okay, in the place of ID, what we have to place? We have to push L. Whether TL is a handle, whether L is a handle? No. TL is a handle? Yes. No, TL is not a handle. Okay, look at the first production of the grammar. S derives TL followed by semicolon. So it is not a handle. Now what we have to do? We have to go to input and perform the shift operation. After shifting, what is the top of the stack? Comma. Now look at this. TL followed by comma. No, it is not a handle. So go to input and you push ID. Means shift operation. Okay. Now look at ID. Whether ID is a handle? Yes, it can be. See, now we have two confusion, right? See, which production we have to apply? ID is a handle, right? ID is a handle. Not only that, L comma ID is also handle. Okay, which is preferred now? L comma ID. Okay, don't shift ID. Look at the stack top. ID is a handle. So if I replace ID with L, what happens? We don't have any meaning for L comma L. So therefore, what we have to do, you just take the handle L comma ID. So L comma ID is replaced with L, right? Now it becomes TL. Stack top is L. Now what we have to do, whether TL is a handle? No. So perform shift operation. What to shift? Semicolon. Right. Now TL semicolon. What we have to do for TL semicolon? Yes, it is a handle. Right. It is a handle. Therefore, this is reduced by start symbol S. Now what is the stack top? Start symbol. Whether input is empty? Yes. What is the configuration of the parser? Accept. So this input is syntactically valid. So validated by shift reduce parser. Okay. So shift reduce parser can't handle ambiguous grammar. Understood? So this is another grammar and this is input. Perform shift reduce parsing for the input. So this is assignment. Thank you.